Section 8.5, Addition, Subtraction, and Complex Fractions. And these are all, of course, still in relation to rational functions. So when we're adding or subtracting rational expressions, we're going to do this the same way you would with numerical fractions. So typically you're taught to get a common denominator, and then add the numerators and simplify, and place the result over the common denominator, and then simplify with the denominator if it's possible. So for example, if we were to have 5/12 plus 11/12, well, we've got a common denominator of 12, so we just add the numerators, so we get 16/12. Then of course these are each divisible by 4, so this would simplify to 4/3. If we don't have common denominators, so 3/4 plus 5/6, one way that you can do this is by multiplying 6 times 3 and getting 18, plus 4 times 5 gives us 20, over, multiply the denominator and get 24, which gives us 38 over 24, and we can simplify this to 19/12. Now sometimes we might be able to use this method with rational functions, but sometimes if we do this it's going to get a lot more complicated than if we do it the way we're also sometimes taught originally, and that's to get a common denominator. So 12 would be the smallest thing that 4 and 6 both go into. We multiply the 4 by 3 to get 12, so we have to multiply, of course, the numerator. We multiply 6 by 2, so of course 5 by 2 is 10. Adding those together we get 19/12, which is what we got before. Alright, so our first example with rational expressions. So again, we've got common denominators. So since we've got a common denominator, we can just write this, add this together over that denominator, 2x minus 1 plus x, over that common denominator of x plus 1. Then of course if we can simplify it, 3x minus 1 over x plus 1, that would be our final answer. I'd like you to try to do this one on your own. So again, we've got common denominators. You'll simply be adding together, or in this case subtracting the numerators. But then make sure that you look and see if you can factor either the numerator or the denominator, and then possibly cancel out common factors. Alright, let's move along to an example that does not have a common denominator. So the first one has an xy and the second one has a y. They both have that common denominator of y, but the first one also is being multiplied by x. So we could make it so we're multiplying this denominator by x, but if we do that, we need to make sure that we multiply the numerator as well. So we're really only multiplying by 1, x over x. Now we've got 7 over xy plus 9x over xy, and when we add those together, we have 7 plus 9x all over xy. Writing this more in standard proper form of the variable first, we have 9x plus 7 over xy. The next example. So we could approach this one using that cross-multiplying method that we learned of, but if you remember, when you do that, you're generally going to have to simplify your fraction when you're done. And so since we're dealing with the x's and polynomials, sometimes it's easier to just go ahead and factor to begin with. So let's take a look at that. The first also that we need to remember is that because we're adding in this denominator, this second denominator, that we can't just look at the factors. So we're going to have to factor. The first one doesn't factor. Our numerator of our second one doesn't factor. But the denominator of our second one, what does it have in common? Well, we can take a 3x squared out of both those terms, and then we'll be left with 2x plus 1. And so now, let's go ahead and compare our denominators. Our numerators are going to stay the same unless we need to multiply top and bottom by something. But let's take a look at what we have. They've both got a factor of 3. The 3 is being multiplied, so we can keep that. This first one has an x to the third. The second one only has an x to the second, so it needs an x to the third. So x to the third times, well, we need to multiply the top by x as well to keep that fraction to be equivalent value. Next, this second fraction has a 2x plus 1, so we'll keep that there. But the first fraction needs that 2x plus 1, so we're going to multiply again top and bottom by 2x plus 1. Now when we write this as one fraction, remember to distribute the 4 to the parentheses, so 8x plus 4 plus x times x gives us x squared, all over that common denominator of 3x squared times 2x plus 1. Again, writing this in standard form, we'll get that as our final answer. Alright, let's take a look at this next example. So again, we've got a lot going on in these denominators, so let's go ahead and factor them first and see what we've got. So the first one, our numerator doesn't factor, x plus 1, and that denominator factors as x plus 3 and x plus 3. Minus 1 over, and then x squared minus 9 is x plus 3 and x minus 3. So we can see that both of those denominators have an x plus 3, but this one has another x plus 3, and this one has an x minus 3. So let's go ahead and see what we've got. Again, let's write down our numerators. And again, they've both got that x plus 3, so let's just give them both that. And then this first one has an x plus 3, so we'll write that one down. But the second denominator needs that, so of course we have to multiply the numerator as well. And then the second denominator already has an x minus 3, so the first fraction needs that, as well as the top. And so now, make sure that you put the parentheses, especially because that first numerator was initially a binomial, two terms. Make sure that you put parentheses around that. That's very important so that we make sure that we actually FOIL that together and multiply them. So let's write this as one big numerator, just our first numerator minus our second numerator, all over that common denominator. Now we've got a minus going on there, so we can't just start canceling things from the numerator and denominator. So let's go ahead and multiply this together. Multiplying the first set of parentheses with that second, x plus 1 and x minus 3, we get x squared minus 3x plus x minus 3. And then we need to make sure that we distribute that negative, or if that was a number, at least distributing that number. So minus x minus 3. And that's all over that common denominator. Now let's combine our like terms on our numerator. We've got an x squared. Combining those x's, a negative 3x plus x minus x gives us minus 3x. And then the minus 3 and minus 3 gives us a negative 6, all over the common denominator. Now let's take a look at complex fractions. A complex fraction is basically a fraction that contains a fraction within a fraction. So that can be either in the numerator or the denominator, or it could have a fraction in both the numerator and denominator. So the first thing we need to do is change this to a regular division problem. Let's just write them as regular fractions with a division problem. And then, of course, remembering that we divide fractions by changing it to multiplying by the reciprocal. So let's take a look at, again, real numbers. We've got 2/3 over 5/6. Well, this means 2/3 divided by 5/6. And hopefully you're not too reliant on that calculator. And so you'll remember that this is the same as 2/3 changing division to multiplication of 6/5, multiplying straight across numerators and denominators, and then simplifying to 4/5. So let's see what this looks like with a rational expression. So we've got 2 over x plus 2 all over 1 over x plus 2 over x. Wow, that's a lot. Let's go ahead and write this as a division problem on one line. So 2 over x plus 2 divided by that whole denominator. Now let's take a little sidebar with this second set of parentheses. In order to be able to change this to multiplying by the reciprocal, we've first got to get it to one fraction. So let's do a little sidebar here and get this together as one fraction. So this first fraction, just like we were just working on, needs a denominator, or an x in the denominator. And the second one needs an x plus 2. So multiplying top and bottom, we're going to get x plus, distributing that 2, we get 2x plus 4 all over that common denominator. Simplifying my numerator, and now I'm going to go ahead and write this division problem. So I've got 2 over x plus 2 divided by that denominator, or that second fraction that we now can flip and change this to multiplication and flip that second fraction. Now we can see that we can cross off these like terms in the numerator and denominator, the x plus 2, and we're left with 2x over 3x plus 4. And let's take a look at one more. Let's first write this as a division problem. And now let's do a little sidebar and rewrite these two fractions that are being added together as one fraction. Again, the first fraction needs an x plus 1 on the numerator and denominator, and the second one needs an x minus 4. Distributing on the first one, we get x plus 1 plus 3x minus 12 all over that common denominator. And again, let's simplify this, combine our like terms, and now let's go back to that original problem, and we can write this as one fraction divided by another fraction. Again, we can change division now, since we've got a fraction divided by a fraction, to multiplication of the reciprocal. Once again, we can see that we have common factors in the numerator and denominator, so we can cancel those. And we're left with 3 times x plus 1 over a common denominator, or our only denominator. Doesn't need to be common, again, sorry, because we're multiplying, but we have the only thing left in the denominator is 4x minus 11. If you have any questions, please make sure you come. These are a couple of difficult sections here, so please make sure you have any questions, you come and ask them, and we'll see you tomorrow in class.